Hello students and welcome to the quick solution of All India Cast Test Series JEE Main 2019 Test 3 Code ENF Physics. Let's move to question number 1. In question number 1, time period T of oscillation of a body in a fluid depends on pressure P, density ρ and surface tension S. Then the time period can be expressed as. So we can say that time period T is function of pressure P raised to the power A, density that is rho raised to the power B, and surface tension S raised to the power C. So if I substitute the dimensional formula of P, rho and S, then it would be T is equal to M1 L minus 1 T minus 2 raised to the power A. Then the dimensional formula of rho is M1 L minus 3 raised to the power B, and that of S is M1 T minus 2 raised to the power C. So if I compare the power of M, L and T on both sides and solving the equation, we will find that the value of A comes out to be minus 3 by 2, value of B comes out to be 1 by 2, and the value of C is equal to 1. So we can say that option 1 is the correct answer. So the correct answer for question number 1 is option 1. Let's move to question number 2. In question number 2, velocity v of a transverse wave on a uniform string is given by v is equal to under root t by mu, where t is the tension in the string and mu is the mass per unit length, that is m by l. The tension in the string is measured as 10.0 Newton, the mass of the string is measured as 5.0 gram, and the length of the string is measured as 2.00 meter. The percentage error in the determined value of velocity is. So it is given in the question that v is equal to under root t by mu, which can be further written as under root t by m into l. So if I take the derivative of this equation, it can be written as delta v by v into 100 is equal to half of delta t by t plus delta L by L plus delta M by M into 100. So in order to calculate the percentage error in the determined value of velocity, we have to substitute the data of these variables. So delta T, so least count of tension is 0.1 divided by 10 plus delta L by L can be written as 0.01 divided by 2 plus delta M by M can be written as 0.1 divided by 5 into 100. So on solving, it comes out to be 1.75%. So option 4 is the correct answer. So the correct answer for question number 2 is option 4. Let's move to question number 3. In question number 3, on the main scale of a vernier caliper, 1 centimeter is divided into 20 parts. On the vernier scale, there are 50 divisions which are equivalent to 2.45 centimeter. The least count of the vernier caliper is. So least count can be calculated as 1 MSD minus 1 VSD. Now we have to calculate what is the value of 1 MSD. So 1 main scale division is equal to 1 centimeter divided by 20. So that comes out to be 0.05 centimeter. In the similar fashion, if I calculate vernier scale division, it is equal to 2.45 centimeter divided by 50, and on solving it comes out to be 0.049 centimeter. So if I substitute this data, 0.05 minus 0.049, so it comes out to be 0.001 centimeter or 0.01 millimeter. So option 3 is the correct answer. So the correct answer for question number 3 is option 3. Let's move to question number 4. In question number 4, mass number A and binding energy of 4 different nuclei X1, X2, X3, X4 are given below. The correct order of their stability is. So we compare the order of stability by the value of binding energy per nucleon. So if I calculate the binding energy per nucleon of these nuclei, then of X1 it comes out to be 5.75 mega electron volt, For X2, it comes out to be 7.08 mega electron volt. For X3, it comes out to be 8.33 mega electron volt, and for X4, it comes out to be 7.55 mega electron volt. Since higher is the binding energy per nucleon, more is the stability. So if I compare the order, then option 4 is the correct answer. So the correct answer for question number 4 is option 4. Let's move to question number 5. In question number 5, a monochromatic beam of light of wavelength 663 nanometer is incident normally on a surface, produces a pressure of 10 raised to the power minus 6 Newton per meter square. The surface absorbs 75% of the incident light and reflects the rest. The number of photons incident per second on a unit area is. This is the surface, and on this a beam of light is falling normally, and in this beam of light let the photons are moving in this way. If n is the number of photons moving in this cross section and the momentum of each photon is h by lambda, then the momentum imparted to this surface can be written as delta p is equal to 3 by 4 of n is the photons absorbed by the surface. So the momentum imparted to the surface can be written as 3 by 4 of n into h by lambda plus 1 by 4 of n photons gets reflected from the surface. So the momentum imparted to the surface can be written as n by 4 into h by lambda into 2. So if I solve this, it comes out to be 5 by 4 n h by lambda. So this is the momentum imparted to the surface. So if I divide by the time delta t, let in time delta t it is the momentum transferred, then dp by dt is the force which is exerted on the surface, and this is equal to 5 by 4 n by delta t into h by lambda. Let the cross section area of this surface is A. So if I calculate the pressure is equal to force per unit area. So this is equal to 5 by 4 n divided by A into delta t into h by lambda. So from this equation, if I calculate the number of photons incident per second on a unit area n dash, this is equal to n divided by A into delta t, and from this equation it is equal to 4 by 5 of p lambda by h. So if I substitute the data, 4 by 5 into value of p is 10 raised to the power minus 6, which is given in the question. The value of lambda is 663 nanometer, so 10 raised to the power minus 9 divided by value of h, that is 6.63 into 10 raised to the power minus 34. So if I solve this, it comes out to be 8 into 10 raised to the power 20. So the number of photons incident per second on a unit area is 8 into 10 raised to the power 20. So option 1 is the correct answer. So the correct answer for question number 5 is option 1. Let's move to question number 6.